Welcome! In this video, we shall refer to the graph theory question. Please make a pause and attempt this question. We shall discuss the solutions afterwards. 25 graph theory specialists meet at an annual dinner. Is it possible that each of them only knows 7 others at the dinner? We can use our knowledge of graph theory to answer this question. If we use a graph to interpret this situation, then we can use the note to denote every person in this meeting. And if 2 persons know each other, then we can indicate by an edge joining these 2 notes. Whereas if 2 persons do not know each other, then there is no edge connecting both notes. Having a meeting with 25 graph theory specialists would mean that there would be a graph having 25 nodes. And in case if each of the person only knows 7 others at the dinner, it would mean that there should be a graph in which the degree of each node is equal to 7. In case if this setting doesn't fulfill some of the theory from graphs, we notice that such setting is not possible. One of the theory we learned is the hand-shaking lemma. Hand-shaking lemma tells us that for any graphs, the sum of the degree of each of the vertices in the graph must be equal to twice the number of edges in the graph. That is, twice the size of the graph. So we can check whether these settings fulfill the requirements from the hand-shaking lemma. We can prove by contradiction. Suppose that there is really such a graph that interprets this setting. Then we try to deduce a contradiction by using the hand-shaking lemma. And if there is such a contradiction, it means that such setting is not possible. So let's suppose that it is possible that each of the 25 people knows 7 others at the dinner. Then we interpret this by a graph G with vertex set V and edge set E. So the vertices represent the people and each of the edge represents the acquaintance between 2 persons. According to the information from the questions, we notice that the number of elements in the vertex set is 25, representing the number of persons in the meeting, and for each of the vertex in this vertex set, the degree is equal to 7 because each of them knows 7 others at the dinner. Then hand-shaking lemma tells us that for any graphs, the sum of the degree of each of the vertices in the graph must be equal to twice the number of edges in the graph. That is, twice the size of the graph. So in our case, when each vertex has a degree of 7, and we have a total of 25 vertices, so 25 times 7 is twice the size of the graph. This would give that the number of edges in the graph is 87.5, but the number of edges must be an integer. So this is impossible that the number of edges is not an integer in this case. Therefore, contradiction exists in our case. So by the proof of contradiction, we have succeeded in showing that it is not possible that each of these 25 people knows 7 others at the dinner.